We now have the Omapper array completely connected and turned on. One important note, when you turn off the console, be sure to press the power button first before you disconnect any of the power cables. So to turn it on, we press the power button. Now this console, it can do both magnetometer and Ohm Mapper. Because we're doing the Ohm Mapper, we use the arrow keys to highlight and select the Ohm Mapper and press enter. Now we're at the Ohm Mapper main menu. We have a variety of options. This is a simple survey for when you're collecting a bunch of lines, but the console has no knowledge of your mark spacing, your line length, or any of your grid information. So when you're using simple survey, you need to be taking good notes so that you know line 1 is 100 meters long, mark spacing is 10 meters, etc. The next option is mapped survey. Mapped survey is where the console knows the grid. So the console knows you're doing, for example, 100 meter long lines and 10 meter spacing between lines and 20 meter mark spacing. The next option is Omapper Geometry. This is a very important parameter to set and check often anytime you make a change to your array. Data view allows you to go back and look at some of the raw data. Data transfer is where you will go to download your data once you're back at the lab at your PC. Finally, system setup is where you go in and set up some basic system parameters. So first, we'll look at the Omapper Geometry. At the top of the screen here, there's a simple little ASCII character art where this here is your transmitter, this here is your rope between the transmitter and the receiver, and this here is your first receiver. Then this here, F, is your spacing from your last receiver to your console. It is important to record all these parameters. The transmitter dipole length, which is C, needs to be the same as the receiver dipole length. And S needs to be some rational factor of the dipole length. So we first set the receiver dipole length, we clear out the field by pressing delete, and now we type in the dipole length and press enter. Because we're using the same dipole length in the transmitter, we highlight the transmitter dipole length, which is C, press delete to erase the field, and type in that dipole length, which is 5, press enter. Now we also need to set up the rope length, which right now I'm going to set it to 5. This corresponds to an end space of 1, meaning the length is equal to your dipole length. So now we press enter. So now I'm going to show you the Omapper Test, which is found from within the System Setup menu. This is a very important feature to verify that your Omapper is working properly. Notice that there's a whole bunch of numbers coming in here. This is the raw data coming out of your receiver array. And notice you get one string of numbers for each receiver. So we have 1 string, 2, 3, 4, and 5. So each time the receivers send out a data packet, we'll get 5 sets of numbers. In this case, because we have 5 receivers. If you had 1 receiver, you get one string, or one set. If you had 2 receivers, you'd get 2, and so on for the number of receivers you have. The first value here is your actual reading. This is already normalized for volts for current. So this is in microvolts per milliamps. The second and third numbers are your receiver and transmitter battery voltages. The fourth number, which is 2 digits, the first digit is the current level from the transmitter. The second number, or the second digit, is the gain for that particular receiver. And one important note here, the first set of numbers in this string of 5 sets of numbers is for 5 receivers. Of course, the first string corresponds to the first receiver, the receiver closest to the transmitter. And the second is the second farthest from the transmitter, or the next one closer to the console, and so on until your last receiver, which is the one closest to the console or farthest from the transmitter. Once again, the fourth set of numbers here, the first digit of that corresponds to the current level from the transmitter. In this case, it says 2. That number should match to the code that's being flashed from the LED on the transmitter. And so that number, in this case 2, should match the code flashed from the transmitter.
Here's how it works. A transmitter electrifies 2 coaxial cables, transmitter dipoles, with an AC current. Current is then coupled to the earth through the capacitance of the cable. A matched receiver, automatically tuned to the transmitter frequency, measures the associated voltage picked up on the receiver's dipole cables. The receiver then transmits a voltage measurement, normalized to current, to the logging console.
And the console has a metronome, and it'll start beeping. This will help you keep an even pace.
The Ohm Mapper can be towed by an ATV, small vehicle, or dragged by an individual with minimal effort.
Thank you for watching, and we hope to hear from you soon.
The Ohm Mapper can be used for engineering, archaeology, and agricultural applications. For more information, call Geometrics in San Jose, California, USA at 408-954-0522 or email us at sales@geometrics.com.